Let me put the class on record and get my slide. Before I begin, I would like to ask if I'm audible enough. So can you guys hear me?
Yes, please. You can.
Yes, please. We can hear you.
Okay, beautiful. Let me check my sound system and be sure that my input volume is, okay, my input volume is fine. So next, let me share my screen and we begin. So today we're looking at causal reasoning. In our last class, which was just 2 days ago, we were discussing inductive reasoning. And I mentioned in our discussion of deductive reasoning that causal reasoning is really a kind of inductive reasoning. So that means causal reasoning shares in the characteristics of inductive reasoning. It's just that causal reasoning is a special kind of inductive reasoning that is reasoning from cause to effect and sometimes from effect to cause. Now, before we do causal reasoning, before we study patterns of causal reasoning, let's first of all find out the different senses of the word cause. First of all, we have proximate cause, which is the immediate cause of something, even if that thing has more remote and foundational causes. So the proximate cause is the immediate cause of something. Example, Samson decided to become an armed robber. It put him in a situation where he engaged in a shootout with the police, and the police killed him. So Samson decided to become an armed robber. And then he landed in a situation where he had to exchange gunfire with the police, and it killed him. So the immediate cause of Samson's death is that he became an armed robber, and that led to his death. We have contributory cause. That's a cause among many other causes. For example, a distressed economy contributed to Samson's decision to be an armed robber and hence to end up being killed. So apart from proximate cause, which is the immediate cause, we have contributory cause. A distressed economy contributed to Samson's decision to become an armed robber. So a distressed economy can be seen as a contributory cause. Then we have necessary cause or cause as necessary condition. When something is a necessary condition for another thing, without it, the other would not exist. Example, without oxygen, life is impossible. So when you need a cause before you can have an effect, then such a cause is necessary. If there's no oxygen, then there's no life. So oxygen is a necessary cause of life. If there's also no water, there's no life. So water is also a necessary cause of life. If there's no food, there's no life. So food is also a necessary cause for life. So these are necessary causes. But we have sufficient cause or cause as sufficient condition. Something could be a sufficient condition for for an effect if the presence of that thing is adequate for the presence of the effect. One does not need to express doubt at seeing the effect when she sees the condition. So for something to be a sufficient cause, such a thing has to be adequate for the effect. Example, to be prevented from inhaling oxygen for 20 minutes is sufficient condition for death. So if you prevent someone from inhaling oxygen for 20 minutes, that is adequate for death. You don't need any other additional measure to bring about death. Another example of sufficient cause, proving that a healthy and sane person calculatedly committed a murder is an adequate condition for sentencing the person to life imprisonment, if this is the appropriate sentencing for such a crime in that jurisdiction. So if the law of a land says that killing or homicide will be punished by life imprisonment, and we go to court and you're able to prove that this person committed this homicide, then that's adequate. That's sufficient condition for life imprisonment, because you don't need any other being in addition. Then we have individually necessary and jointly sufficient conditions. We can say there are several individually necessary conditions for an effect, and that a combination of these conditions becomes sufficient for the effect. So an effect could need several necessary conditions, each of them necessary, but none of them is sufficient. So for instance, life needs oxygen. Oxygen is necessary. Life also needs food. Food is necessary. Life needs water. Water is necessary, but none of them is adequate for life. So we can have individually necessary and jointly sufficient conditions. So in order to have life, you need to bring together all the necessary conditions that will be sufficient for life. But in life and science, it is usually difficult to determine what number of causes are jointly sufficient for an effect to occur. So let's see this example. Oxygen, water, food, and health are independently necessary conditions for a human being to stay alive. But they and some other factors we may not know yet are sufficient for staying alive. So oxygen is necessary for life, water is necessary for life, food is necessary for life. Even sunlight is necessary for life. Without sunlight, there will be no life. Okay. But how many of these causes do we need before you can have life? That's the difficult question. You wouldn't know, we don't know how many causes are sufficient in order to have life. You can assemble water, sunlight, food, oxygen, and yet you don't have life. That means that something is missing. You have to keep searching for it. So it is not usually it's not usually easy in science to arrive at sufficient conditions. It is easier to identify necessary conditions. Then we have probabilistic cause. Probabilistic cause is the opposite of necessary cause. This kind of cause is theoretically not necessary. It's not a must for the effect. Example, a crisis within the economy, the lack of a job, and the need to marry and settle down are probable causes of Samson's decision to become an armed robber. So we call it probable cause because a lot of people pass through these conditions and they did not end up as armed robbers. In fact, I also passed through all these conditions. I didn't have a job. I needed to marry and settle down. In fact, I found my wife when I didn't have a job. So that means that the need to get a job became very, very important when I found someone to marry. So those things are probable causes, but they are not necessary. I, for instance, did not end up an armed robber because I found someone to marry and I still didn't have a job. Then we have causal agent as cause. The causal agent is also a cause. You can have causal agents. Example, Clement is the cause of the crisis. So Clement is a causal agent. Then we have causal chain and causal web. Causal chain is when you have so many causes, each one leading to another. But causal web is when the relationship between the causes is more like a web than a chain. So two contributory causes could occur simultaneously. That's a causal web. Now let's look at causal chain. Example of causal chain. Samson struggled throughout his primary, secondary, and tertiary education. He graduated but couldn't find a job. He attempted self-employment but did not show enough determination to succeed in his chosen craft. He went to a bar one day and met a friend who introduced him to a gang. Samson agreed to join the gang because he was hungry and out of cash. He joined the gang and became an armed robber. He and his gang had a number of successful robberies. On one of those escapades, they ran into the police. So this is a chain of causes. There was a shootout and Samson was hit. Because he was hit, he was rushed to hospital and where he died of gunshot injury. So from his primary, tertiary, secondary, tertiary education down to robbery and then to dying in a hospital. It's a chain of causes. Then we have causal web. It could be that the police officer who killed Samson. Now, causal web is when several causes are happening simultaneously, contributing to the same effect in a simultaneous manner. They don't need to come one before the other. They could all occur at the same time, but they are all contributing to the same effect. It could be that the police officer who killed Samson did so because he, the officer, aimed his gun correctly, whilst his colleagues did not. And at the same time, Samson got killed because he squeezed his trigger to kill the police person before the police killed him, but found that there were no more bullets in the firing chamber of his gun. So this is a causal web. Samson aims his gun at a police officer. The police officer aims his gun at Samson. Both of them squeeze their triggers at the same time, but the difference is that Samson had no more bullets in the firing chamber of his gun, and the policeman still had bullets in the firing chamber of his gun. So that's a causal web. Then we have informal causal reasoning and patterns. So now we have seen the different kinds of these different senses of the word cause. We have probabilistic cause, we have necessary cause, we have contributory cause, we have proximate cause, we have causal chain and causal web, we have causal agent, and so on. Now, let's look at informal causal reasoning patterns. And during tests and exams, you'll be given questions to identify what kind of causes. So you need to start learning how to identify the different kinds of causes or the different senses of the word cause. Informal causal reasoning pattern. So causal reasoning is a type of inductive argument attempting to establish the causal relationship between phenomena or events. A causal claim indicates that something causes another. A causal hypothesis is an initial speculation made in relation to a causal claim, a supposition offered as a starting point for future further investigation. Now, I want to look at two things. First, the various informal causal reasoning strategies for arriving at causal claims. So that's what we're going to look at now, the various informal causal reasoning strategies. We have informal patterns of causal reasoning, which all of us use naturally as human beings. We don't need to be scientists or to be trained to use them. So informal causal reasoning patterns, strategies are the ones that we, the ordinary human beings, use every day. And then the second one, the various experimental strategies for confirming causal hypothesis, but that's not for this semester. So that one is the special or advanced causal experiments that scientists use. So it is not in this semester. So we just look at the informal causal reasoning strategies, which all of us use as normal human beings. Now, John Stuart Mill, in his book titled A System of Logic, proposed 5 approaches for detecting causation by observation. And we are going to study 3 right now. And the 3 of them are the relevant difference reasoning, the common thread reasoning, and the concomitant variation reasoning. Okay. Let's begin with the relevant difference reasoning. This is a method of reasoning that identifies something that occurred differently from others as the cause of an effect. Something that occurred differently from others as the cause of an effect. A is the difference among others, so A caused the effect. Now let's see an example. This is an example. I've always taken tea and bread for my breakfast. Yeah. But on a certain day last month, I fell sick shortly after my breakfast. I treated the illness and felt sick again last week after my breakfast. So I asked myself why I have fallen sick on these two occasions after breakfast. And it occurs to me that on these occasions I had taken marmalade with the breakfast. So I checked the information provided on the marmalade container and I see that the product has expired long ago. So I suspect that this is the reason why I have fallen sick twice, since I've always taken tea and bread without health implications. It means that the expired marmalade becomes a relevant difference in explaining the possible cause of the two illnesses. So this example is saying that I have always taken bread and tea for my breakfast and I've never had any problems. But on an occasion after breakfast, I felt sick. Even when I treated it, I felt sick again after another breakfast. And I was asking myself, what is making me sick after breakfast? The same breakfast that I've always taken all my life. And then I asked myself, what is different in these two breakfasts? And then it occurs to me that I had added, I had bought a certain product that I will use in garnishing my bread. And, uh, and I have used it on those two occasions. So that product, which I bought recently to add to my breakfast, is the relevant difference in explaining my illness after breakfast. So that's how we identify a relevant difference. You need to find out if there's a problem in the environment, then you need to ask yourself, what is different? What is new in this environment as a way of explaining this problem? If a problem appears in an environment, then it means that there is something new that has happened in that environment, which is the cause of the problem. Such a thing needs to be identified. Then we have the common thread reasoning. This is a method of reasoning that identifies something that occurred in all the instances that have led to a particular effect. So there could be a problem in different cases. We could have several cases, all of them having a particular problem. And then it is possible that it is the same cause that is causing this problem in all the cases. That will, if you are able to find such a cause or call it a common cause, then you call it, well, it's a common cause, but identifying a common cause is called common thread reasoning. It means that that cause is a common thread that is running through all the cases. So the argument goes like this. A is the common thread among all the events. So A is the cause. Now let's see an example. When I bought the marmalade some months ago, I had gone shopping in the company of my neighbors, and we had all bought the same stock of marmalade, which expired at the same time. So assuming my neighbors are equally sick, they all traced the cause of their illnesses to the same product. It means we have all identified the expired marmalade as a common thread in all the cases of this particular illness in the neighborhood. So that's how you identify common thread. So if not only me, but my neighbors also bought that product, on a particular day, we all went shopping together. And they are all falling sick after their breakfast. And then maybe we start interacting and we all find out that, oh, it is this product that is causing this. It means that that product is not only a relevant difference in explaining my problem, it has also become a common thread in explaining the problem of all those who bought it. So sometimes in identifying an epidemic, something that is happening to many people in the community, first of all, you need to get a single sample, investigate the sample, find out what is happening differently in that sample or in that sample's life. If you're able to identify a relevant difference in a single sample, then you ask yourself whether that relevant difference is also a relevant difference for other samples. If it happens that the same relevant difference is also a relevant difference for all the samples in the community that are having the same problem, then it means that you are not only dealing with a relevant difference, you are also dealing with a common thread. Then we have concomitant variation. This is a method of identifying the degree of occurrence of something rather than its simple presence or absence. Now, relevant difference and common thread are strategies for identifying the simple presence or simple absence of a cause. But this method called concomitant variation is not about simple presence or absence. It's about identifying the degree of occurrence of something. We use it when we cannot eliminate a particular cause from the environment. Example, carbon dioxide. So it is useless to use relevant difference to identify carbon dioxide as a cause of ill health because carbon dioxide is always there. So we use a method that measures its degree or intensity. Let's see example. It was revealed through research that high blood pressure is exacerbated in regions whose soils have low levels of selenium. Now, this is a metal that exists in tiny quantities in every soil. And because of this, we cannot measure for its absence or presence. We can only account for the effects of varying degrees of it, and hence the discovery that it seems correlative with the ability of our bodies to keep our blood pressure normal. Now, selenium is a metal that is found in every soil. But it was discovered that in those places where the quantity of selenium is too low or too small in the soil, people suffer high blood pressure. So that means that a certain quantity of selenium needs to be in the soil for those who are living above that soil to have normal blood pressure. In that case, for such a problem, you are not looking for the presence or absence of selenium. What you are looking for is the degree of selenium in the soil. So that's a method we call concomitant variation. Let's give a second example. It was discovered that high levels of sulfur dioxide pollution in the air was responsible for high rates of deaths in London between November and December 1952. Now, there's no way to eliminate sulfur dioxide from the air. So the experiment discovered the causal connection by comparing the increase and decrease of the effect, which is number of deaths per day, to the daily variation in the degrees of sulfur dioxide fumes in the air. So this kind of experiment, you are not looking for the presence of sulfur dioxide. You are rather asking what is the quantity of sulfur dioxide in the air that is causing something. So if the quantity of sulfur dioxide in the air is normal, people will be healthy. But if it is abnormal, then people will have problems. So to find out whether it is a cause of a high rate of death, you first of all count the number of deaths each day, and also each day you measure the quantity of sulfur dioxide in the air. So every day you compare the number of deaths to the quantity of sulfur dioxide. And then you might discover that a certain degree of sulfur dioxide is responsible for a certain number of deaths. And then you might also find out that a certain degree of sulfur dioxide doesn't cause any problems at all. That's concomitant variation. So we are done. Those are the three methods of informal causal reasoning, which all of us use. Now let's look at some causal fallacies, or fallacies of causal reasoning, or we call them bad causal reasoning. These fallacies are committed when the link between an alleged cause and effect depends on a causal link that doesn't exist. The first fallacy we'll look at is called the post hoc ergo propter hoc. Post hoc ergo propter hoc, or the fallacy of inferring causality from chronology. Example: for the first time today, I took beans for breakfast. and I performed wonderfully in my mathematics test. Therefore, a breakfast of beans is very crucial to mathematical proficiency. So this is the fallacy of thinking that just because something happened before something, it is the cause of that thing. Another example, you can say the president and the vice president had an argument before the economic recession. Therefore, the argument between the president and the vice president was responsible for the economic recession. So that's another example. So you have all kinds of fallacies like that. Some people even say, this kind of fallacy is connected with a lot of superstition. Some people believe that when they knock their feet, when they hit their foot on a stone, then something bad might happen that day. So if anything bad happens that day, they will say, oh, it is because I hit my foot on a stone that something bad happened to me today. Or a lot of business people believe that the first trader who buys, a lot of sellers, a lot of traders believe that if their first sale of the day was cheap, if they didn't get much money from their first sale of the day, then it means that is how the rest of the day is going to go. So for that day, they are not going to make much money. So they believe that it is only when their first sale of the day is lucrative that they will sell well. That it is if the first buyer gives them a lot of money, that they will be successful that day. So those are fallacies of post hoc ego propter hoc. Then we have non-causa pro causa, or the fallacy of exchanging or confusing cause for effect. So you take cause and regard it as effect, and then you regard the effect as cause. Example, Michael is a poor student because he performs poorly in examinations. But that is a fallacy. To correct that fallacy, you say Michael performs poorly in examinations because he's a poor student. So it is not because he's a poor student. It is not because he performs poorly that is a poor student. It is because he's a poor student that he performs poorly in examinations. If you didn't study well, then you perform poorly in examinations. You don't perform poorly in examinations before you fail to study well. Then we have oversimplified cause. This occurs when there are many causes and the argument identifies only one of them as a cause. So we call it oversimplified cause. Example, the Cameroonian team won the trophy because their coach is paid a higher salary. So this is an oversimplified cause. A higher salary alone cannot give victory to a team. Then we have false common thread. We have seen common thread and we have the false one. When we infer a common thread as a cause when it is not. Example, all the academically bright guys in my class have cars, so I will get a car as part of my desire to be academically bright. So this one is not a true common thread. Confusing correlation with causation. Now, what is correlation? Correlation is when two things happen together, always happen together. Then causation is when one of them causes the other. But the fact that two things always happen together doesn't mean that there is a direct causal relationship between them. It doesn't mean that one of them causes the other. Example, each time a car moves, we see smoke coming from the exhaust tube. Therefore, the smoke causes the car to move. As a child, you see a car moving and you see the smoke pushing backwards. And then as a child, you imagine that, oh, it is the smoke that is pushing backwards that is propelling the car forward. So correction, the smoke is not what causes the car to move. Both the movement and the smoke are caused by the engine combustion. So we shouldn't always confuse correlation with effect. Slippery slope. When we suggest that a relatively insignificant event will cause a more significant event, which in turn will cause an even more significant event, and the order of significance continues to increase without adequate justification as why each significant event will lead to a more significant event. So a progressively dubious chain of premises, usually consequences, is often employed to support a conclusion or claim. So when we say that something caused another thing that is more serious, and then it leads to something more serious again, and then they lead to something that is even more serious, and then the level of seriousness just continues as if there's a demon from hell that is, propelling the whole thing. This is the fallacy of arguing that if A is allowed, it will trigger a set of events that will eventually lead to Z. And it is only a matter of time to go from A to Z, to slip down a slippery slope from A to Z. No, this should not be a fallacy. So this kind of fallacy is committed regularly. When Donald Trump was campaigning for president of USA in 2016, some Democrats were saying that if he becomes the president, America will fight up to 10 wars, 10 or more wars. Eventually that didn't happen. So that was a slippery slope argument. Just because Donald Trump is aggressive in attitude doesn't mean that that is going to happen. So this should not be a fallacy if the causal movement from A to Z is justified. But it is a fallacy if the causal movement is not justified or justifiable, which means that it is fatalism. That is an extreme version of determinism. First example, if Donald Trump becomes the president, America will fight many wars. Second example, it is wrong to believe in God because then you will eventually believe in not just God, but all kinds of spirits. And then you come to believe that spirits have all kinds of power, which is superstition. And then you come to believe that inanimate objects have spirits, which is animism. And then you come to believe that everything that has spirits and power to do something or the other, thereby ultimately destroying your ability to evaluate cause and effect in natural terms. So someone says you shouldn't believe in God because if you believe in God, then eventually you land in a condition where you believe that everything around you has power, including the chair you are sitting on, the pencil you are holding in your hand, even the laptop in front of you or your phone have spiritual powers. So that argument is called a slippery slope argument. Third example, I cannot allow my child to go outdoors and play in the compound. This is because if I do, she will jump fence and go into the streets. If she goes into the streets, she will run away with any stranger. If she runs away with any stranger, then I'll never see her again. If I never see her again, I'll be miserable for the rest of my life. If I'm miserable for the rest of my life, I'll commit suicide. So for the purpose of the avoidance of suicide, I will not allow my child to play outdoors in my compound. So this argument says that if you allow your child to play inside your compound, a compound that is actually locked with fence, that will ultimately lead to your suicide. So that's a slippery slope argument. So in our next class, we shall be studying informal fallacies. And at this point, I'm going to take questions. Remember to watch your videos regularly and do all the exercises in your textbooks. So at this point, I'm going to take questions. If you have questions, please indicate by raising your hand so that we address the questions. And after that, I'm going to upload this video immediately on your Sakai so that all those who couldn't attend this class could start watching the video. All right, so questions. Bismarck, go ahead.
Sir, good morning.
Yeah, good morning.
Sir, please can you further explain the causal chain and causal web? It's confusing me a little.
Yeah, it doesn't need to confuse you, and you don't even need an explanation to know what chain and web means. Causal chain is that there are a series of causes, one leading to the other. This causes this, then it causes that, then it also causes that. That's a causal chain. But causal web is when all the causes are happening at the same time. When there are so many causes happening at the same time, that's a causal web. If, for instance, now a bad economy could be caused by several things at the same time. Politicians could be embezzling the public funds, and then inflation is also causing problems. So these are two causes happening at the same time. And then in addition, let's say, so there's a lot of bribery going on. Probably even policemen are taking bribes on the road. So that's another cause of the bad economy. And then also, probably the educational system is not having a high quality. Students are not being educated well, so they are coming out with bad certificates, or let's say bad training. So all these things are happening at the same time, and they are all having one effect, which is a bad economy. That's an example of a causal web.
Okay.
Yeah, so any other questions before I give you the video? Okay.
No, sir.
All right, so please, whenever you are doing your assessments, whenever I give you an assignment or a test or exam, please remember to do it in the middle of the night between 12 and 2 a.m. so that you don't encounter network problems. A lot of people have complained of not being able to submit or do their assignments, and I usually ask them, when did you do it? And they will tell me in the morning or in the afternoon or in the evening. So they are actually responsible for that problem. So please be very clever about when to do your assessment.
Okay, sir. Thank you very much.
I want to make a contribution.
Yeah, go ahead.
I said, I think when they use Chrome, it is better.
Yeah,
like it's better to use Chrome for the Sakai assignments.
Oh, that's good.
Yes.
But remember that the different web browsers, I know the web browsers themselves depend on the internet network supply. So even if you are using an efficient web browser and there is insufficient network, there is still a risk. So please use the Chrome like you said, and also remember to do it. If you make your first attempt had technical problems, then suspend it until a time of the day when it should be safer to do the second one. That is why I give you.
They open the water, so I go back of it.
If you burn up your 2 chances, then it is difficult to give you another one. All right, so please have a nice time, a nice weekend. Work hard so that all of you will be great.
Thank you, sir.
All right.
Thank you.